Hola a todos. Hello everyone. I'm Wei Gao. I'm happy to share my latest research, which is recently published in ACS Applied Materials and Interfaces. Our study focuses on understanding the interaction between the molybdenum carbide nanoparticles and the carbon supports. So first, the transition metal carbides, like the molybdenum carbide here, they are promising for many catalysis reactions. And recently, people find they may have better performance with the carbon support, including the graphene and also carbon nanotube. But the interaction between them are not well understood. So, so, so first, our study focus on the interaction between nanoparticles and the flat graphene. We find that regardless of the stoichiometry, the metal atoms they serve as the anchoring points. And what's more, we find the non-stoichiometric ones they have more low coordinated metal atoms, and so they exhibit stronger adsorption. And we find there is a strong correlation between the adsorption strength and the electron transfer. So now we move from the graphene to the carbon nanotube. First, I would like to share with you a simplified and efficient method to model the carbon nanotube, because normally it's very computationally expensive to model the whole carbon nanotube at the DFT level because of huge number of atoms. But here we use the curved graphene model. It highlights the most important feature of carbon nanotube, which is the curvature, or to say the curved surfaces. Okay, now by loading the nanoparticles on curved graphene, we find an important curvature effect. The nanoparticles show stronger binding on concave surfaces and weaker binding on convex surfaces. And the adsorption strength is directly linked to the degree of the support curvature, which is very interesting. And furthermore, influenced by the interaction strength between the support and the nanoparticles, we find the charge state of the nanoparticle can also be modulated. And interestingly, the carbon dioxide, the adsorption of it can also be tuned by the support curvature and the local environment. That to say, the nanoparticle on the convex surfaces show stronger adsorption for the carbon dioxide. So to summarize, our findings highlight the potential to tune the chemical activity of supported molybdenum carbide on the carbon supports. And we can manipulate it by carbide stoichiometry, support curvature, and the local concave or convex surfaces. The results here can provide insight for a rational design of relevant catalysts. Okay, thank you. Thank you for your attention. Bye-bye.